Let's go ahead and first sketch the region first. So I've got y equals 2x, y equals 6, y equals 1. So I'm going to make a rough sketch first. So y equals 2x is just a line 0, 0 up 2 over 1. There's that. And then y equals 6 is a horizontal line. Y equals 1 is also a horizontal line. And the y-axis is here. So the region that we're going to be looking at is just this region in here. And we are going to do cross sections. So when we talk about cross sections, remember the volume is just the area of the two-dimensional picture. And we're perpendicular to the y-axis. Oh, so this is where I have to be careful. So we are going perpendicular to the y-axis, so this is where we have to use dy. So my rectangle is going to go like this. So that's a dy rectangle. And it says you are going to use right scaling triangles with base in the xy plane. So what that means is this is the base of the triangle. So that's this side of the triangle. And then you have a right triangle that looks like this. So that's my right triangle. And we need to find the area of this triangle. And it tells me that the height of this triangle is exactly 5. So we know that is 5. So area of a triangle is 1/2 base times height. Notice the base is this part of the triangle, which is just the length of this rectangle right here. So remember, we do right minus left. So I want everything in terms of dy though, so I can rewrite this equation as y over 2 equals x. So this distance here is y over 2, right? That's my equation. So it's 1/2. The base is y over 2. The height of the triangle it told us was 5, so that's the area of the triangle. The thickness is dy, and then we're going to integrate it from 1 to 6. This would be the setup to find cross sections where we have these triangles coming up from the bottom to the top. Okay, the next one, we're going to do 4 different cross sections, but the region is going to be the same. You're going to be looking at a circle. So x squared plus y squared is a circle centered at 0, radius is just 5. This is my picture. And we're going to take cross sections perpendicular to the x-axis. So that means this is my region. So that means your rectangle is going to be perpendicular to the x-axis. So I know that I'm going to use dx everywhere. Okay. Now, first cross section is a square. So that means one side of the square is this side right here, this rectangle that I drew. So that's that. So this is my square. Remember, we just need to find the area of that square. So I just need to figure out the side of this square. So notice we go top of the rectangle to the bottom. So this is the equation of this circle. But if I solve this equation of this circle for y, it's really plus or minus root 25 minus x squared. So the top part of the circle is the equation, the positive square root of 25 minus x squared. And the bottom part of the circle is the negative square root of 25 minus x squared. So it's those two equations put together that make the complete circle. So if you think about this side of the square, the top is the positive square root, minus the bottom is the negative square root, so minus the negative, so you have this. So really, it's 2 root 25 minus x squared. So that's what this length of this rectangle right here is. So what's the area of a square? I'm going to go ahead and put it here. It's just the side times itself, or squared. The thickness of that squared is dx. I can integrate it from my x coordinates are -5 to 5. That will give me total volume using squares. Okay, equilateral triangle, same thing. But we do need the formula for the equilateral triangle. It's root 3 over 4 times the side square, that's the area. So again, this rectangle right here, that's going to be the side of this equilateral triangle. But this side on this triangle is the same as this side on this square. So we already figured that out. That's this distance right here. So what's the area? Root 3 over 4. What's the side? 2 root 25 minus x squared. So area squared, that's the area of a triangle, integrated from negative 5 to 5, and that will give you the entire volume. Okay, I'm going to erase the ones we have here so far. Let's go ahead and do the same thing. Let's just do part C, which is the semicircle. Okay, again, this rectangle or this up and down that I drew is the side of the semicircle. But we already figured out that this diameter is 2 root 25 minus x squared. We just have to find the area of this semicircle, which is pi halves radius squared. But the radius is a half of this distance. So if the whole thing is 2 root 25 minus x squared, the radius would just be root 25 minus x squared. So I have pi half, this is my r squared, thickness is dx, integrated from negative 5 to 5. This would be your total volume using semicircles. And we're going to skip the last one, D.